So last time we studied these equations, VBO plus V over 2 equal to Q minus QBO sine V over 2. And for we study is this case, okay? And from that one, I remember we have this important plot. This is phi, and here, sorry, if I didn't put this free flight, basically this is a free flight, okay. So these are free flight angles, and this is the VBO. So here we have this graph, if you remember, and we have done this one. So this is the maximum value of the free flight range angles. And what is that one? So if this is Earth, this is a burnout, and this is the re-entry. This is what we define as free flight, the range angles, okay? So for this case, last time we discussed, and what is QBO? QBO by definition is the VBO times R BO squared divided by mu. So basically, depends on the burnout position velocity, we can calculate Q. And for this case, we're interested in this, and usually this one corresponding is for elliptic, the free flight orbit. Okay, and this is the most used. So I will put a little bit more time on this case. Okay, so that's what we done. So from here you can see for given any, as long as the phi is not maximum, then say we have certain numbers. Say let me call this a star. Any numbers, as long as for any number less than the maximum value of the free flight range, then we always seen from our the calculations last time, we always have two possible solutions. So for example, this is the local horizon. So that means you would have two options. Either you can shoot high, and that is the phi BO1, and or you can shoot low, and phi BO2 corresponding to the value here. Either the flight path angle can give you the same the flight range, okay, the free flight range. So that is what we have done. So today I'm going to study in particular is these numbers. And so the topic corresponding to this one is called the maximum. Range trajectory. And again, this one is in particular only valid for the case we study here. Okay, so basically this is a whole continuous stories we're talking. And this is one standalone section in our textbook. So here I put the titles here. And so basically for this one, we're looking for is this value. So actually we have partially done these answers before in the previous sections. I already give you this number, but we can do this one here one more time. So basically the maximum value is occurred, we're solving for this one. And from here you can see the maximum value corresponding to have the only unique solution of phi BO, right? So here that is the phi BO corresponding to, I would say, the maximum. And you know this maximum is corresponding to this value, doesn't mean that is the maximum value of phi BO, okay? So basically that's corresponding to is this number here. So you can see at the maximum under the maximum conditions, we only have one unique solution for VBO. So the answer to the most systematic way to answer this question, what is this number? Again, here we can reconsider this problem statement is this. Either you can take the partial derivative of the VBO of psi respect to whatever, and then you're looking for the, say, if this is the functions, if this is a function, this is a function f of x, the maximum happened is when f of x prime equal to 0, right? We can use this single calculus principle to look for what is the maximum value of the x star. We can apply the same thing to these functions, right? But we don't need to. Why? Because if we stick with this, the fact is this, when the maximum occurred, we only have one unique solution. So that means from here, when the maximum condition occur, we only have one unique solution. And the unique solution is this, when the whole things become 1. If you remember, if you flip your lecture notes, why we have, for other cases, why we have two numbers, because we have two possible solutions for dealing with arc sine. Okay, so here basically the textbook, if you have time to read textbook, the simple way to answer the questions for this one is simply make this is to 1. So here is the things, the maximum range conditions will occur when 2 divided by 2BO and VBO sine. So that means when this one equal to maximum, and this one will be equal to 1. Okay? So that means if we set up this equal to 1, basically this number, this equation has this one equal to 1. So that means when we take arc sine of 1, we only have one unique solution. If this number is less than 1, then taking the arc sine, we have two solutions, right? You know the logic. Good? Okay. Taking this approach will be much easier than taking the traditional way. This will involve a lot of the calculations. I tried this, and basically using the one whole page and very fast scratch and reaching the same result. Okay. So we go to this one. So in this way, the first one we see what is the maximum value. So therefore from here we can see the maximum value basically equal to QBO and 2 minus QBO, and divide this scalar to there, and we take arc sine and multiply by 2. Okay. So in this way, the first one we determine what is this value, then we can calculate this one. Okay, as long as Q is less than 1, as long as QBO is less than 1, and here we discuss is this case, then this value always exists. And on the other side, you can see when QBO is greater than 1, then you can see the whole thing is greater than 1, there are no solutions. Okay, so right now we have solved this one, then we can solve for what is corresponding VBO. And so for that case, again, we're taking out this equation here, this one equal to 1. So that means sine Q VBO plus V, and that is the maximum value here, and equal to 1. Okay, right now the right one is I taking up these equations here. Be good? Okay, so from here, then we can solve for the VBO and Q VBO plus this one divided by 2 equal to arc sine of 1. Basically, this is pi over 2. Okay, so therefore, VBO VBO equal to pi over 4 minus VFF maximum divided by 4. So this one, this number is this number here, corresponding flat path angle. So here, so for example, once you figure out the key numbers of the launching the bonus problems, then you know the RBO, BBO, then you should know the Q. So from that case, once you identify the Q, then you should be able to tell what is the longest the free flight range that missile can reach. And from there, you can determine right away that will be the in the intercontinental ballistic missile or not. Okay, so that's the reason why I said at the burnout positions, the R and V are the key parameters for us to tell what is the maximum range of that missile can perform. You good? Okay, so I think that's it.